Good morning. Now we are going to discuss excitation table of flip-flops. Excitation table and truth table. This is the truth table and this is the excitation table of flip-flops. See, this is the truth table of a flip-flop, and here you have this is a flip-flop, and this flip-flop has two inputs. As this is a JK flip-flop, the outputs are Q and Q bar, and depending on the value of J and K, if a clock pulse is applied, here you have a clock pulse also, and when this clock pulse is applied, depending on the value of J and K, this value will either be set, reset, or complements, or stores the previous value. Okay. See, this is a truth table, and what is the meaning of this X? That is don't care condition, and I will show you how. Suppose that the previous value of Q is 0, and suppose that the previous value of this is 1. And now here also two cases, that means 0 and 1. Here also we have two cases, 0 and 1, and this is 0 1. That means this is, and now we are going to discuss what will happen when these are the values. For example, suppose that the value of J and K are 0 and 0, and the current state is 0. Current output is 0. That means J and K are zeros, and the current Q is 0. What will happen? After that, after this, the next one is, that means as 0 0, this is storing the previous value. That means 0 is stored, and if 0 and 0, if it is 1, again it is storing the value 1. That means here if it is 0 0, suppose that 0 0, if the current value is 0, next state also will be 0. If current value of J and K is 0 0, and the previous value of the input is, or previous value of the memory element or Q is 1, then it is storing the previous value 1. Okay. Now if it is 0 1, what will happen? 0 1, that is setting the value. That is 0 1 is resetting. 0 1 is resetting the value. 0 1 resets. That means 0 1 resets means if it is 0, it is keeping that value, and if it is 1, again that will be switched to 0. If it is 1 0, if the previous value of this is 0, it is set. That means if it is 1 0, what will happen? Whether it is 0 or 1, it is setting that value to 1 and setting the value to 1. And now it is 1 1. If the previous value of Q is 0, then that will be complemented. If the previous value is 1, that is complemented to 0. So this is the extended truth table for JK flip-flop. This is the extended truth table for JK flip-flop. And now we are going to have, for designing sequential circuits, we need an excitation table. So we are going to decide upon what is the previous value of the flip-flop and what is the current value of the flip-flop. That means this is the present state. This is the present state, and this is the next state. That means if this is the present state of the flip-flop and this is the next state of the flip-flop, what should be the value of J and K that we are going to decide. Okay. Now there are four possibilities: 0 0, 0 1, 1 0, and 1 1. Okay. See, after verifying, just see here in this extended truth table, this is the previous value and this is the next value. Here I am going to fill up this table. Going to fill up this excitation table. That means what is the present state and what is the next state. See here, if you have a transition from, if we have a transition from 0 to 0, that means the previous state is 0 and the next state is 0. Then if the current state is 0 and the next state is again 0, what are the j and k values that is possible for a 0 to 0 transition? See, here this is a 0 to 0 transition. In that case, that means if the transition is 0 to 0, if the transition is 0 to 0, what are the possible values of jk? J and k can be 0 to 0 transition, the value of j can be 0, 0, 0, 0, and here this is 1 to 1 transition. Here again you have 0 to 0 transition, 0 to 0 transition. In that case, you have 0, 1. That means the value of j can be j and k are 0 and 1. Here there is 0 to 1, 1 to 1, 0 to 1, and 1 to 0. That means here, if you want to have a transition from 0 to 0, see the jk values can be either 0, 0 or 0, 1. That means this j should be 0 and this k can be, that is a non-care condition, that means 0x. That means if you want to have a 0 to 0 transition, that means if the previous value is 0 and the current state also should be 0, the j value should be 0 and we are not interested in the k values. Whether it is 0 or 1, that is not a requisite for this transition. That means you should have this j to be 0. That means that is why you have 0x. That means I am going to have 0x. That means if you want to have a 0 to 0 transition, definitely you should have this j value 0 and the value of k can be either 0 or 1. Now 0 to 1 transition. For 0 to 1 transition, what is the value of j and k? 0 to 1, here 0, 0, 1, 1, here there is a 0 to 1 transition, 0 to 1. In that case, the value of j and k are 1 and 0, 1, 0, and here also you have a transition from 0 to 1, 0 to 1. In that case, this is 1, 1. That means 1, 1. See, if you want to have a transition from 0 to 1, the value of j should be 1 and this is varying. Okay, that means in that case I am going to have 1x. That means this is 1x. That means if you want to have a 0 to 1 transition, definitely this j should be 1 and we are not interested in the value of k. Now, see, now if you want to have 0 to, if you want to have 1 to 0 transition, 1 to 0 transition, what is the value of j and k? 1 to 0 transition is, here 1 to 0 transition, 1 to 0, in that case the value of j and k are 0, 1, 0, 1, and here 1 to 0 transition we don't have, here also we have 1 to 0 transition, in that case here it is 1, 1, 1, 1. See these two j and k values. Here the k value, this is j and this is k. Now the k value remains 1 and this j value is varying. Okay, that means j value is varying. So in that case, this is x. That means this, we are not interested in the value j, but k should be 1. That means this is x1. And now what is 1 to 1 transition? For 1 to 1 transition, what is the input? 1 to 1 transition, 1 to 1. What is the value of j and k? 1 to, here it is 1 to 1. 1 to 1 transition, it is jk is 0, 0. Now what is the value of 1 to 1? 1 to 1, and here also we have 1 to 1, 1 to 1. In that case, this is 1 0. This is 1 0. Here in this case, the k value should be 0 and this is varying. That means that is x 0. X 0. That means this is the excitation table, or this is the excitation table for the JK flip flop. And in this case, if you want to have a 0 to 0 transition, the J should be 0. If you want to have 0 to 1 transition, J should be 1. If you want to have 1 to 0 transition, this K should be 1. And if 1 to 1 transition, K should be 0. So that is all about excitation table, and the truth table for J and K. And this is useful for design of sequential circuits.